Hi, this is Dan from SolveBOTICS. Thank you for joining me today. I love to tinker, design, and experiment, which is why I designed and built this mobile command center. And because I wanted the mobile command center to support a variety of projects, I designed it to be as flexible and as reconfigurable as possible. This system is designed so that you can quickly and easily access the embedded Raspberry Pi so that you can add or remove hardware or even replace that Pi with a different or newer model. So in the Mobile Command Center overview video, I demonstrated how the bezel and underplate assembly can be removed. In this video, I'll be expanding on this topic to demonstrate the complete process for disassembly and replacing that Raspberry Pi with a different model. I currently have a Raspberry Pi 4B installed in this system, and I'll be replacing it with a Raspberry Pi 5. I will also be installing a custom circuit board I designed that will connect the OLED Status Display to that Raspberry Pi 5. If you own one of these systems or are considering buying one, then consider this video the official guide for disassembly and reassembly. If you haven't seen the overview video, the Mobile Command Center is a system I designed and built to work with the Raspberry Pi 4 or Raspberry Pi 5. I designed the system to be portable, rugged, and to offer maximum flexibility to make working on robotics projects, tinkering, and exploration much easier. Because when you're working on those projects, there are many problems you have to solve. But figuring out how to move your keyboard, monitor, power supply, and mouse shouldn't be one of them. Before I move on, I'd like to say thank you to everyone who has subscribed and liked my previous videos. I'd also like to thank those of you who have purchased the Mobile Command Center. You are all helping to make a huge difference. And I can't help but be inspired by your thoughtful feedback, your kind words, and your incredible support. So if you're new to this channel, once again, my name is Dan, and I'm the founder of SolveBOTICS. And this is a place where I like to share projects I've worked on or I'm currently developing. And the ethos behind SolveBOTICS is to learn, apply, and solve. And to me, these are not just words, but rather a plan of action that is helping to solve difficult and challenging problems in the past. So with that in mind, let's gather the tools we'll need to get started. The first tool you'll need is a 2.5mm hex driver, and this is used for removing the screws from the bezel and the bottom two panels. The next tool you'll need is a 3/32 inch hex driver, and this is used for removing the underplate assembly. As you remove the screws, it's great to have a small magnet that you can hold next to each screw to prevent it from falling out and getting lost. You will also want to have one or more small containers to collect the screws as you remove them. When you get to the point where you're removing or installing the Raspberry Pi, it's great to have a 5mm socket to loosen or tighten the hexagonal standoffs that hold the Raspberry Pi in place. To protect the display, you will need a piece of foam. This 1-inch piece is a good choice, as is this 1/2-inch thick piece. But if you don't have these available, then a microfiber cloth is also a good choice. A microfiber cloth combined with a piece of cardboard will work. The goal is to provide a cushion to protect the display as you work on the system. The final item needed is a 1 to 3 pound object that can be set in the keyboard area to be used as a third hand. An example would be this cardboard box that can sit right in this area, or as you've seen in some of my other videos, this robot works as well. With all the tools ready, the first step is to make sure the Mobile Command Center is fully powered off. After issuing a shutdown command, wait at least 10 seconds before turning off the main power switch. With the power off, use the 2.5mm hex driver to begin loosening the screws of the bottom two panels and bezel. There are a total of 28 screws that need to be removed. Remove the bottom two panels, then remove the bezel from the system. You are now ready to remove the underplate assembly. These red arrows show the 6 440 screws that need to be loosened to remove the underplate assembly. Use the 3/32 inch hex driver to remove the 6 440 screws. Place the 1 to 3 pound object on the keyboard area. Then place a piece of foam or soft material between the object and the underplate assembly. Gently tilt the underplate assembly so that it rests against the object. Shown here is an alternate method using the R22 robot and a piece of foam. With the system opened, the power distribution board is on the left. The Raspberry Pi and its cables are in the center of the underplate assembly. So at this step, there are 6 cables that need to be disconnected, and they are the voltage current meter cable, the power switch cable, the first USB cable here that provides power to the Raspberry Pi, then these 2 USB cables that provide power to the 5-volt cooling fans, and then the final cable down here is the USB cable for the keyboard. So I will go ahead and disconnect these now. When disconnecting, just grab it by the green boot in the case of these cables. Okay, and then at this point, this entire assembly can be removed from the case. Then, using that piece of foam from earlier, you'll want to use it to protect the screen. So I like to use that larger piece so I can just kind of rest the entire underplate assembly on it, making sure that none of these cables are between that display and the foam. Shown here is a close-up of the power distribution board. There are 5 connections that need to be made to this board. For reference, these connections and their locations are shown in the photo. These connections will be shown again during the reassembly steps later in this video. So this is what the underplate assembly looks like when it's been removed from the system. And this is the cable for the voltage and current meter. And this is the cable for the power switch. And then you have the USB cable for the Raspberry Pi power and the USB cables for the cooling fans. And then finally, that 6th cable was the keyboard cable, and it's here. So we take these cables and we place them aside. The Raspberry Pi itself in this system has 10 cables that need to be disconnected, and that would be, the first of these is the micro SD card extension cable, and then there's the USB-C power cable, the HDMI cable, these 2 USB port cables that go to the front panel. There's this USB cable that provides the touchscreen capability. There's a USB cable underneath that is connected for the keyboard. In the back is the Ethernet cable. Then there's this power lead cable that provides 5 volts to the display. And then finally, there's this cable for this OLED status display that I added to the system. So I'll begin by disconnecting the micro SD card extension. Disconnect the USB cable. Next, disconnect these USB cables. Sometimes it's hard to get that little tab for the Ethernet cable, so I like to grab a hex driver and just push that upward and then pull back on this cable. Disconnect the power lead for the display, and then I'll be disconnecting this connection for the OLED status display. Now's the time when I want to grab the 5mm socket and use it to loosen these hexagonal standoffs. And with that, the Raspberry Pi 4B is now free from the system. And it's probably a good idea to take this card and keep it with this Raspberry Pi. Remember to push it in to release it. At this point, I'm ready to put the Raspberry Pi 5 into the system. So the first thing I want to do is make sure all the cables are out of the way. And then next, I want to make sure that these USB cables are flat against this cable manager plate. Okay. So the next is I'm going to take my Raspberry Pi, orient it this way, and just place it over the hexagonal standoffs that are installed. For this step, it's time to install the hexagonal standoffs. If you're planning to use only the Raspberry Pi in the command center, then 6mm long hexagonal standoffs can be used. If you will be adding a circuit board with a stack-through header as shown, then you will need to use 12 to 13mm long hexagonal standoffs. The 12 to 13mm long hexagonal standoffs are needed to achieve the correct board spacing between a Raspberry Pi and a circuit board that has a stack-through header. Install the appropriate length standoffs, then use the 5mm socket to fully tighten them. Reconnect the extension cable for the micro SD card reader. Next, reconnect the USB power cable. There are two HDMI connectors on the Pi 5 and Pi 4. These are labeled HDMI 0 and HDMI 1. The cable used in the command center can only reach HDMI 1, so that is the connector to use. Do not try to connect to HDMI 0. Doing so may damage the flat ribbon cable. Next, connect the Ethernet cable. Locate the USB keyboard cable. It's the one that is secured to the cable manager plate. Plug this cable into a bottom USB port. Next, locate the USB touchscreen cable and plug this cable into a top USB port. Locate the two panel mount USB cables and plug these into the remaining USB ports. The next connection to make is the power lead for the main display. It is important to connect this to the correct pins of the Raspberry Pi GPIO header. The two red leads are the 5V leads, and they need to be connected to pins 2 and 4 of the GPIO header. The black lead connects to ground, which is pin 6 of the GPIO header. These images show the correct connections for this power lead. After this connection, the Underplate Assembly is ready to be reinstalled into the mobile command center. For my system, however, I'm currently using a custom-made OLED Status Display. The connections required for this module are power, ground, and 2 I2C signals. Currently, I'm using these leads to make these connections, but I'll be replacing this OLED Status Display with a newer and improved module, which I'll talk about next. I've introduced the OLED Status Display in a previous video, but I've improved it here by adding a 4-pin JST connector to the back of it. This enables me to quickly connect the power, ground, and I2C signals the correct way every time. The other end of the cable plugs into a 4-pin JST connector that I added to the custom circuit board that I designed. This also guarantees the correct connections for the power, ground, and I2C signals. Shown here are both components fully connected. The main touchscreen display used in a mobile command center requires 5V from the Raspberry Pi. The silkscreen labels on the circuit board enable me to make those connections quickly and correctly. To install this board, I need to disconnect the power lead for the touchscreen display. I then seat the board onto the 40-pin header of the Raspberry Pi. These silkscreen labels will help me to reconnect the power lead. Hexagonal standoffs are used to secure the board to the Raspberry Pi. The original OLED status display is removed and replaced with the improved one. This is a prime example of the flexibility of the mobile command center and how it allows me to develop and make improvements to my own hardware. I then connect the 4-pin cable of the OLED status display to the circuit board. I insert the micro SD card with the operating system, and now I'm ready to reinstall this underplate assembly back into the mobile command center. Once again, place a 1 to 3 pound object on the keyboard area of the command center and place a piece of protective foam against that object. Move the underplate assembly into position, making sure to move the cables out of the way. Then let the underplate assembly rest against the foam. There are a total of 6 cables that need to be connected. 5 of these cables plug into the power distribution board, as shown here. A 6th cable connects the USB keyboard. Start by plugging in the 3-pin cable for the voltage current meter. Next, plug in the 2-pin cable for the main power switch. Then you'll want to connect these 3 USB cables. The top one, which looks a little bit different than these two, is for the Raspberry Pi power. So it goes in the top slot. And then these next 2 are for the 5-volt cooling fans. These are all 5-volt, so it really does not matter the order that you plug these into the board, but I like to keep them straight. So if you follow that same order, Raspberry Pi, cooling fan 1, cooling fan 2. Then the final connection here is for your USB keyboard. So find this cable and then locate this other female USB cable that's tied to this plate, which I call the cable manager plate, and then plug these in. Okay, and let's review, make sure we have everything connected. Meter, power switch, 1, 2, 3 USBs, and then the keyboard. So 1, 2, 3, 4, 5, 6. Everything's ready. Tilt the underplate assembly back into the mobile command center. As you do so, you will need to make sure the USB cables clear the support on the left side of the case. As you tilt the underplate assembly back into position, gently push down on the cables to clear the supports. Now it's time to secure the underplate assembly using the 6 440 screws. The locations for these screws are shown here. Use the 3/32" hex driver to install the 440 screws, but do not fully tighten them yet. Press the underplate assembly against the support behind it, then fully tighten each 440 screw. Shown here are a few examples of the supports making contact with the underplate assembly as the 440 screws are being tightened. So at this point, the 440 screws are all tightened on this system, and I'm ready to power on. And that's something I want to do before I put the bezel back on. There are 20 screws for the bezel and then 8 more for the panels. So if there's a problem with my installation, I want to know that before I put everything back together. So I'm going to go ahead and power on. Everything is powered up and working properly, including the custom-made OLED status display. The next step is to reinstall the bezel and to secure it to the command center by tightening the 20 M3 by 6mm screws as shown here. After the bezel is installed, secure the two bottom panels with 8 and 3 by 6 millimeter screws, as shown here. After this final step, the reassembly is complete. So in this video, I successfully replaced the Pi 4B with a Pi 5. I also added an upgraded version of my custom-made OLED status display. Only one final adjustment remains. There, now it's complete. This concludes the guide for disassembling and reassembling the mobile command center. I hope you found value in today's video. If you'd like to learn more about the mobile command center, then visit us at SolveBOTICS.com. You can also find our store on Etsy. This is Dan from SolveBOTICS signing off. Thank you for watching and have a wonderful day.